We just got finished talking about congruent figures. Now we're going to talk about similar figures. This is lesson 25D. And of course, I've got links in the description, and there should be some at the end of the video to help you if you need it. When two figures have corresponding angle measures and corresponding sides in proportion to each other, they're similar figures. Take a look at these two triangles. The one on the left is obviously smaller, but look at their angle measures. This one's got a 65-degree angle and a 90, and this one's got a 65 and a 90. We know that the interior measures of a triangle have to be 180 degrees. When we add the 65 and 90 together, we get 155 degrees. If we take that away from the 180, we're going to get 25 degrees. So that has to be a 25-degree angle, and that has to be a 25-degree angle. They have the same angle measures even though they're different sizes. And triangle ABC is similar to triangle DEF. And that's the notation for similar. These two triangles have the same shape, but they're not the same size. And when two angles of one triangle are equal to two angles of a second triangle, the third angles of these triangles will also be equal. So because that's a 65 and a 90, and that's a 65 and a 90, we know they both are going to have the same angle measure here. When the three angles are the same, that's angle, 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 the two triangles will be similar. But also, when the lengths of the sides of one triangle are in proportion to the lengths of the sides of a second triangle, both triangles are similar. So here we have two triangles, and they have the same measures. So their ratio is 1 to 1. They're the same, see? So they can be similar, but these are also congruent, aren't they? They can have different but proportional measures and be similar. This one's got a 3-inch side, this one's got a 6-inch side. That's 3 times 2, isn't it? This side is 3 inches and that's 6 inches. That's 3 times 2. This is a 4-inch side, that's an 8-inch side. That's 4 times 2. So this one is twice as big as this one. We can write ratios comparing their sides. We have 3 over 6. We have 3 over 6. We have 4 over 8. And that's a half. These all equal a half, don't they? All the ratios equal half, so the length of the sides are proportional. We can say that triangle ABC is similar to triangle DEF. See? And we can use similar figures and proportions to solve problems when we can't find a distance by measuring. Here we have a little girl that's 3 feet tall who's casting a 2-foot shadow. We don't know how tall her father is, but he's casting a 4-foot shadow. We can find the father's height by using proportions. We put the girl's height 3 feet over the father's unknown height of x. That'll be our x. We could even use F for father if we wanted to. We put the girl's 2-foot shadow over the father's 4-foot shadow, and now we have our proportion. And if you remember proportions back from lesson 6, we cross-multiply 3 times 4, which will equal 12, and 2x should equal 12. If they both equal the same number, we know they're in proportion. So we do the 3 times 4, that's 12, and it's going to equal 2x. We can divide both sides of the equation of this equal sign by this 2 coefficient, and we get 6 equals x. So we know the father's height is 6 feet tall. Now, if the proportions really confuse you, there's going to be a link to video 6F way back in the GED playlist where we talked about solving proportions. Okay? So we know he's 6 feet tall. Now we have two triangles. We have a big blue triangle with a little red triangle inside of it. And it's telling us that triangle PSR, this big blue triangle, is similar to QRT, this little red one. And it wants to know what the length of PS is. So we take a look at the information that's given. We can see that QT is 3 inches. We can see that this base is 5 inches. And this piece from S to T is 7. We can write a proportion. Line QT is 3. We don't know what PS is, so that's going to be our X. We know this base is 5 inches, and this base is 7 plus 5. We need the whole thing because this is the whole triangle, isn't it? So that's over 12 for line SR. We do our proportion. 3 times 12 needs to equal 5x. 3 times 12 is 36. We divide both sides of the equal sign by this 5 coefficient, and if you do it real quick on your calculator, you'll get 7.2 will be x. So we know that this side is 7.2 inches. So if this confused you about this algebra work we just did, you need to go back to lesson 18, okay? All right. This is telling us right off the bat that it's an isosceles triangle, ABC, ABC. So this big blue one is isosceles, and it's got this little red one inside, so that's going to be isosceles also, isn't it? It's also telling us that line DE is 2.25 inches right here, and it wants to know the length of AB. So we can do a proportion. We look at the information that's given to us. We have DE is 2.25 inches. We don't know what AB is, so that's going to be our x. We know that CE is 5 inches, and that's going to be in proportion to AC, the 10 inches. We need to cross multiply. 2.25 times 10 is going to equal 5x. That's going to give us 22.5 is equal to 5x. We divide both sides by 5, that coefficient right here. And we get 4.5 for x. So we know line AB is 4.5 inches. Now it's asking us what is the measure of angle CDE. CDE. So it's asking us what this measure is inside right here. Well, we know it's an isosceles triangle and that this length is the same as this length. That means if this is 30 degrees and we take that away from the 180 degree interior measures of a triangle, that's going to give us 150 degrees. And that angle is going to have to equal that angle because it's isosceles. We divide 150 by 2 and we get 75 degrees. So what is the measure of DEC, this one right here? Well, if that's 75, that's 75. And what's the measure of CAB? CAB, this one. Well, it's isosceles. If that's 75 degrees, it's going to be similar to that angle, isn't it? That's going to be 75 degrees, and that'll be 75 degrees. Okay? Take a look at this one. We've got two triangles. It looks like one is a flipped over, shrunken version of this one. They both have a 40-degree angle. They both have a 90-degree angle. It's telling us that this line is 7.5 inches. This one is 2.5. This side is 3 inches, but we don't know what this one is, and it wants to know the length of GI, so that's going to be our x. We can write a proportion. So which line corresponds to 2.5? The 7.5. This 3-inch one is going to correspond to this one. So we have 2.5 over 7.5 is going to equal 3 over x. We can do our little cross multiplication. We get 2.5x equals 3 times 7.5. That's going to give us 22.5 on this side. We divide both sides by the 2.5 coefficient, and 22.5 divided by 2.5 is a 9. So we know line GI is a 9. It's 9 inches. And if you look, if we multiply this times 3, 2.5 times 3 is 7.5, and 3 times 3 is 9. Yeah, it's in proportion. This one is 3 times bigger than this one. And which angle corresponds to GHI? GHI. So they're talking about this angle right here. Which other angle corresponds to it? Well, it would be this one down here. We know that's 40 and that's 40 and that's 90 and that's 90. It would have to be that one, wouldn't it? So what is this angle measure right here? Well, if that's 40 and that's 90, we take it away from the 180 and get 50. That tells us that that one would also be 50. So that's 50 degrees and that's 50 degrees. And these two triangles are similar. Okay? They're different sizes, but they're still similar. Now, you're going to have to look for needed information given in a word problem that isn't given in its diagram. Sometimes you're going to read a word problem and it'll have a diagram that goes with it, but the information won't be in the diagram. It'll be in the word problem. So you'll have to add it to the diagram or do it on your scratch paper. You can draw your own diagrams if needed. And even in this one, we needed 12 for this base measure, and we had to add the 7 plus 5 to get it. So it was a little tricky, okay? You should be now ready to do the skill focus on page 305. And there's going to be a link to the Chapter 10 Grade 8 playlist. There's only a few videos in there, but my advice is you need to watch this. There's going to be a link in the description, and there'll be a little link that you can click on at the end of the video. I'm also going to put a link to 6F for proportions in the description, and a link to the previous videos for lesson 25, all about triangles and quadrilaterals. Our next video is going to be using proportions in geometry, 25E. So take it easy, take it slow. Make sure you understand each of these before you go on to the next lesson, okay? Because like I always say, I build upon each lesson, all right? And have a great day, and I'll see you next time. Bye.